Ladies and gentlemen, as we continue our journey through Optimistic Tunisia 3, we are about to embark on panel 2, where the focus will be on energy, greenhouse gas emissions, mitigation, and technologies as a critical exploration into the innovative solutions that drive sustainability in the energy sector. Commencing our discussion is the insightful presentation on reducing fugitive emissions in the energy transition era by Mr. Hamdi bin Salem, General Manager of HYTORC. Mr. bin Salem's insights will shed light on strategies to minimize fugitive emissions, a crucial aspect of the energy transition era. Moving forward, we will delve into continuous oil and gas facilities monitoring with AI super resolved open satellite imagery for cost-effective leak detection. Mr. Hichem Mokni, CEO of NextAV. Mr. Mokni's presentation promises to provide a technological perspective on cost-effective leak detection through advanced satellite imagery and artificial intelligence. Our attention turns to nanotechnology for the energy transition with Dr. Kamel Bennaceur, CEO of Nomadia Energy. Dr. Bennaceur will share insights into how nanotechnology can play a pivotal role in facilitating the energy transition and enhancing sustainability. Continuing our exploration, we have the privilege of hearing from Dr. Houda Benjannat, General Director of Organisation Méditerranéenne de l'Énergie et du Climat. Welcome, Dr. Houda. Dr. Benjannat will elaborate on pathways to a net zero energy future for the Mediterranean region, providing a regional perspective on achieving a net zero energy future. To facilitate an engaging dialogue and Q&A session, we are honored to have Mr. Sofiane MASMOUDI, Vice President of the Oil and Gas and Chemical Market within the Middle East region at Bureau Veritas. Bureau Veritas Abu Dhabi, actually. Mr. MASMOUDI will guide us through the intricacies of energy, GHG emissions mitigation, and the transformative technologies that underpin this crucial sector. This panel is not just about technology, it's about redefining the energy landscape with sustainable practices. I encourage each of you to actively participate, ask questions, and contribute to this vital conversation. Thank you for your engagement, and let's make this panel a source of inspiration and actionable insights for a sustainable energy future. Mr. Hamdi bin Salem, the floor is yours.
I move down, right?
Yeah, move down, yes. So
there we go, yeah. Thank you so much, ladies. Thank you, Simonir. Ladies, gentlemen, distinguished delegates. I'm very proud being a Tunisian to be among you today. It's an honor to have such brilliant minds among us today. So I hope my contribution will help you all to learn something out of this today. I'm not trying to commercialize anything out of my presentation or the company I work for. The idea here is to exchange experiences and best practices. Perhaps there is something for one of you or the government as such to implement at a different scales. So I work as the general manager of HYTORC. I've been here in Middle East for the last 16 years, working in the construction industry. Then back in 2010, I moved to the oil and gas, and I have been an oil man for a long time. And it's something which is really was on my conscience to think more about the climate, think about more the environment, and we as a human being, how we can, within my framework, to contribute to the overall planet. So I will touch on the definition and the impact of the fugitive emissions, specifically the methane, which is associated with the oil and gas industry, And I will talk more also in depth about the bolted joints, which are the key, I would say, source of the fugitive emissions. The technique of or the program of lead detection and repair, or also known as LDAR. Detection has been covered already by Siriva, and I think Hichem will talk about that more. So our technology is not about detection, it's more about the mechanical aspect of it. So how we fix things, how we design them from beginning, so to avoid and prevent this from happening. So the technology of, or the whole program of HYTORC environmental leak protection, we'll look into a case study. So that case study will give you a sense of what contribution we can do. And I will do a closing statement. So this is the whole spectrum of oil and gas, from exploration and production to gas and oil, also processing plants, storage, transportation, distribution. So in the hydrocarbon industry, this industry contributes significantly to the fugitive emissions. So, and when we say fugitive emissions, we are here specifying the methane being not only CO2, the methane being more impactful than CO2. Therefore, the focus will be on that gas and how to prevent it. So in all phases, we have emissions. So that's why the technology we have will also tackle all of those phases of the process. So the nature of fugitive emissions makes them difficult to assess, but their level is significant, around 5% of global emissions from this heavy industry. So historically, detecting fugitive emissions or even considering them in the greenhouse gases is quite complicated. So it's something being I wouldn't say ignored, but not given that enough attention to consider during the design of static or rotating equipment, or throughout the detection phase during the operation of the plant. So this is something which is we need to consider while designing, and this goes to, of course, EPC contractors, goes to the operators, and down to the contractors who are actually doing the job. So it has to be considered within the design stage. Moreover, the government has to look into perhaps sort of subvention to help and encourage actually the contractors to take into consideration these emissions during the design stage. The methane emissions by segments. So from the gas production phase, we have more than 48 comes from during this phase of the project or the production. Oil production 20%, distribution being the pipelines, also the conventional transportation, transmission and storage, and processing. So as I said, methane leaks are 25 times more impactful than CO2 to the global warming. So that's a fact. It's debatable as well. 25% could be much more. So there is here some studies from some agencies like EPA or IEA. They say it could go up to 80%. So that's a lot. That's really harmful. That's really harmful to the greenhouse. 16, for example, we take the example of the US. In the US, there is more than 16 million tons, metric tons of methane emissions that is released in the atmosphere. And that is the cost of it, the social cost of it, not the direct, is around 2.3 billion per year. So the scale of USA, this is how much it's costing. That's a social cost, not a direct cost. On average, just to give you a hint, so 1 ton of methane is costing around $2,000 for 166. And that's a lot, versus the CO2, which is only 185. So this is how bad in terms of impacts to the environment. So as I said, there is a difficulty to trace it. There is a difficulty to also implement it during the design stage of any project or plan or plans. So we need to really revisit these phases, and also the regulations from government side as well to implement very stringent process here. So digging a little bit deeper here. So when we say fugitive emissions, oil and gas plants, so we need to know from where, we need to locate from where the emissions are coming. So the statistics show that most of the valves, they leak. And even visually don't see it, but they leak a lot of gases, followed by relief valves, flanges and pumps, and tanks. So these are the, I would say, the static equipment, which is within the any facility, but also we should not ignore the contribution in terms of emission of the rotating equipment, such as turbines, compressors, pumps. So all these kind of equipment, reactors as well. So they emit a lot of methane. So the methane emissions may be accidental or deliberate. Emissions are brought on by equipment leaks, faulty seals or joints. When natural gas cannot be used or retrieved economically, it may be purposefully expelled or burned rather than sold. And this is what we call by flaring. So flaring is not a fugitive emission, but is the highest contributor when it comes to pollution, 100%. So flaring, and also sometimes we just expel it without even flaring it, the excess of gas. So that is something also which is not discussed here, not studied here, but something to look into. Leakage or discharge of gases from pressurized equipment and components inside plants, such as valves, piping flanges, pumps, storage tanks, valves, and compressors. Just to picture what we are talking about. So here are the static equipment, such as heat exchangers, reactors, pumps, generators, flanges in all types and all classes, BOPs, the pressure control equipments, manways, Christmas tree or the wellheads, turbines, valves, etc. So just to name few, these are all subject to emissions. So all those equipments we just have seen are connected together with bolts or welded. So can be welded or bolted. For example, the pipelines. Pipelines are welded or bolted. What we're gonna look into is this piece, which is the bolting. The welding, most of the time, it goes through, the quality is all right, no issues. But here, where you have a lot of moving parts, the bolt, the gasket, the seals, so on and so forth, this is the risk. This is from the risk where it's coming from. On average, in a oil and gas processing plant, we can have from 10,000 up to 100,000 bolted flanges. So we have like this configuration up to 100,000 of these. So these are all a risk in terms of emissions. So what we can do about it? So the program or the technique within for example, the norms and the regulations in oil and gas or IEA, they use something called, the program called leak detection and repair. So for the leak detection and repair, you can use different technologies, equipment. I will leave my colleague talk more about them. I think Sirida talked about that. Maybe you're gonna touch on that as well. So for example, for instance, at HYTORC, we use infrared cameras to detect the gases. And then we can use also the type that Sirida spoke about. So these are detectors without using any imaging. It's detecting the gases with certain sensors. So a typical refinery or chemical plant can emit 600 to 700 tons per year of VOC from leaking equipments, which we just named. So the best way to do it, since it's operational plant, we have to use the program of leak detection and repair. So facilities, what HYTORC can do is, with our technology, we can assist from the design stage throughout the repair, if there is emission, and also to train and qualify people how to use, or operators how to install these kind of flanges. Facilities can control emissions from equipment leaks through LDR, and also by replacing leaking equipments with leak-free components. As I said, this is more mechanical, so we talk more about how mechanically we can fix those issues. So HYTORC can help in reducing those leaks. We identify the leaks. We have a solution for flange alignment, bolts control, and uniform sealing with while reducing the time to repair. So all the components of the flange. So as we have seen, there is a flange itself, and then you have the gasket or the seal, and you have the bolts. So a lot of moving parts here, and this is what we address, and this is what we advise and also give the full study and reporting about it. Solutions provide both joint integrity to prevent future leaks. This is a snapshot about the technology. Conventionally, it has been done this way. So you have two operators, one from the front side, operating the torque wrench, which is a huge mechanical equipment, to tighten the bolts. And on the back side, you have another operator holding the back side of the bolt so it doesn't turn.
An injury occurring on the backside of the flange can be just as devastating.
There is also a safety aspect to it.
The HYTORC washer system.
The HYTORC technology with the HYTORC washer, we have brought along with our tooling, which are the equipment for assembly. We also have this technology, which helps to align the flange and apply a consistent torque in terms of Newton meter across the whole flange, therefore avoiding the leak from happening in the future. So so this is the technology. It comes in different sizes, different materials, matching the specification of the flanges and so on and so forth. So this being installed in the front side of the flange. So the flange, as I said, could be a different size, could be a different material, different class as well. This one at the front, there is no audio, but it's okay. I will develop. This one being fixed at the back side.
The knurled surface prevents the back nut from turning.
And then we bring the equipment with the adjusted sort of dual socket. As you can see here, we don't have operator on the back side anymore. Less risk, less human error here. And he comes with the equipment to tighten that bolt uniformly and also with high accuracy, therefore avoiding the risk of leakage. We don't need to get too technical here. So this is the conventional method. When you apply a torque, when we use a torque wrench to tighten those bolts, you have lateral loads, and these lateral loads debend the bolts. Therefore, there is a risk of leakage, and also there is a lot of friction here on the surface of the flange. Therefore, there is a loss of energy, a loss of forces, and if you want to apply 1,000 Newton meter, you perhaps end up with 700, 800. And if you don't tighten properly, then this might leak. This technology will help you, of HYTORC, to have coaxial forces. So the action and reaction is happening on the axis of it. So you don't need this reaction arm. You don't need the backup wrench anymore. Less human error, and therefore getting a uniform load and consistent with the target of torque value. So this technology has won the Spotlight Technology of the Year in OTC in Houston. Is that something proven? Just here to emphasize on the point that this is an experiment. This is a flange of 8 bolts. So did I touch something I shouldn't? Okay, yeah. So if the target of the torque is, I would say, for example here, 80,000 foot-pound, and you are using the conventional method with people using their hands or hammers and reaction arms, the actual value on each bolt it has a lot of scatter. It's way far in terms of standard deviation from the target. Therefore, you have a huge risk here for leakage. So while using HYTORC technology, the washer, that precision you get will get you minus plus 3% standard deviation from the target value of the torque. So obviously here you have less risk for leak. Here you have high risk of leak. Among that, we have also another technique, which is called parallel joint closure. With the same pump, we connect 4 tools, and they close in parallel fashion the flange altogether. So if you apply a force here and you close it from one side, you might damage the gasket, and that's not good. It will crack, and it will leak. So we close it in parallel fashion. We apply the load and in very uniform way, therefore protecting the flange, the bolts, and the gasket. And that is something also recommended by ASME, which is the Association of the American Society of Mechanical Engineers. I talked a lot about the tools. So these are the tools. This is how they look like. So these are hydraulic tools. They tighten the bolts. They are heavy. They are bulky. They are dangerous, high pressure. They are used along with this pump connected. However, we revolutionized the whole thing. So we have them connected to softwares. So they are intelligent. They record how much torque we have applied. They also tell the operator how much torque he should apply. So it goes both ways. So this is for data quality. This is for QC, quality control, and also avoiding any human error. A lot of softwares we use for data capturing, for also QC traceability, a wide range also of tools. Most of them, they have Spotlight Technology Awards in Houston as well. So here we have a case study. This case study is in Turkey. We have a lot of case study, but this one is the most interesting one. So we detected a leak in which is over 50,000 ppm per year in one of the flanges, and they allowed us to come in and do more surveys. And we did the site surveys. We detected and measured the leaks using another technique here, but it's still okay, not imaging, but different one. So what we have done is we brought in our specialists. They trained the workers as per the ASME guidelines. We upgraded all the fasteners here with a HYTORC special washer, and we did the proper selection of tools. We customized tightening procedure. We have done the software calculation, the full procedure, what tools to use, how much torque we need to apply, and so on and so forth. So there is a full report giving the steps of the procedure, plus the documentation and quality. So after implementing our technology, there was no leak detected, plus the time saved, and it is safer and easier. And the HYTORC washer has been standardized in all relevant refinery applications. So this is how it looks like before. So this is the imaging showing some fumes or vapor coming out of the flange, and here, no more. So we actually reduced 88,000 in more than, I guess it was around 60 or 70 flanges, 88,000 of VOC per year, and that's a lot. And in terms of value, dollar value, we talk about around 2 million saved here, US dollars. So this is how efficient mechanically we can be. So this is all about it. Everything you need to eliminate fugitive emissions. With HYTORC, we have the quality of the tools, we have the engineers, we have the software, we train. We are involved in different phases of the projects. So methane is really bad, and one of the bad gases that really can hurt the climate, and we can address it. We can work with the operators. We can work with the EPC contractors, or even third parties like technology providers, like the gentlemen who are here, and work, perhaps find a way to optimize this solution and make them more cost effective. My closing statement is, again, I'm very thankful for this opportunity. And besides all what you are doing from the industrial aspect and our jobs, definitely there is something we can do among us. And there is no single person here who doesn't use a plastic or any of those kind of petroleum derived products. So it's a fact, we cannot change it. In 2050, will be more than 10 billion people. We still need the conventional energy sources, and we just need to find our way to transition smoothly and rapidly to more, I would say, renewable energies and less emission energies. Hopefully, this has been fruitful and beneficial for everyone, and thank you so much. Yeah.
Thank you very much, Hamdi.
Welcome.
We are going to make a small pause just to welcome our official delegation from Tunisia. They are going to say a few words, and then we come back to our panel. Is that okay for you? Yeah, thank you very much. Let me invite them.
Let me help you out.
As soon as you are ready.
نحكي على البلاستيك.
بدي يحضر فينا.
نقول لكم انتم ولا نقول لبعضنا مرحبا بالحضور الكريم. ça fait vraiment plaisir. بنات وابناء تونس وسفراء تونس، صحيح فما وينو ساعة السفير، لكن هذاك المجال الدبلوماسي، لكن الكلنا نعتزوا معناتها ببناتنا وولادنا اللي يمثلوا تونس. والحمد لله في 15 دقائق سمعت حاجات اللي تثلج الصدر، والانطباع الطيب والصدى الطيب كلهم في مجاله. ديما نقول لي جون اللي موان جون، كي نسمع فما عباد معناتها تبارك الله لهم مش برشا، نصف قرن معناتها في العمل الدؤوب، نصف قرن راه 50 حكايه فارغه. كي نشوف تبارك الله دي جون حاضرين هنا، نعرفش ما يعملوش حتى 20 25 اللي نحب ولا نكره به من باب المسؤوليه، ولا حتى انتوما ولا حتى تبارك الله معناتها اللي قداش من 30 سنه في قريب تبارك الله معناتها توا كان نحكيو مع حاجه عجبتني اللي انا شخصيا نخدم عليها، هو نخدموا الاجيال المقبله، الاجيال القادمه اللي نعملوه الكل لينا، صحيح لينا للونتوراج نتاعنا، لعائلاتنا، لاولادنا اللي معانا، لكن نخدموا مثلا تو احنا في الصحه، وزاره الصحه قاعدين نحضروا في استراتيجيه الصحه تونس 2050. سي دومان دون 25 ans. Mais peut-être je ne serai pas là. Mais la majorité d'ici présents seront ici. Donc شنو حضرنا؟ احنا مثلا تام تو اللي حضرته اليوم مع يوم الصحه بمناسبه الكوب 28 التغيرات المناخيه اللي كما تعرفوا ما تهمش منطقه ولا جهه ولا حدود، ما عادش فما حدود. والكوفيد علمنا برشا حاجات، علمنا اللي العالم الكل قريه كبيره بدون حدود. تذكروا في مشاكل البافيت والتلقيح وجواز التلقيح، وما تدخل البلاد كان بالتلقيح وما تمشي كان بالتلقيح. واحنا في تونس لقحنا للتوانسه ولقحنا لغير التوانسه. علاش؟ خاطر الصحه حق لكل مواطن. والمواطنه مانيش باش نعمل درس نتاع المواطنه معناتها اللي موجود معاك، المواطنين نتاعك صحيح، لكن اسكو تتخيل انت المواطنين نتاعك لاباس عليهم وصحتهم باهيه وترضى انه يجي عبد اخر مثلا مرض معدي ولا حاجه باش يعديهم؟ دونك نخدموا للاجيال القادمه مع بعضنا. شنو الاسباب نتاع التغيرات المناخيه معناتها اللي يلزمنا زاد نقضيو عليها؟ ما نقضيوش على نعالجوا النتائج كما في الصحه. ما نستناوش اون برانسيب حتى واحد يمرض ونداويوه، ماذا بينا نخدموا على ليتاب معناتها لي زيتاب الاوليه، التقصي والوقايه. عملت اجتماعي اللي كيلكو موا افيك لي ستارت اب تونيزيان اللي يخدموا في مجال الصحه، ايمان مني بالقدرات نتاعهم. ابناء تونس في معناتها تحدي وكيفاش يقولوا معناتها تجاوز الصعوبات. انا في بالي كي تلاقينا معناتها il avait une vingtaine ومعاهم معناتها المشجعين لي زاكومبانياتور، خاطر كيف راهو الكلكم تعرفوا اللي احنا نقولوا باللغه العاميه البلاد تمشي على كبارها. هو البل ما تمشي على كبار، تلقاه الكبير معناتها يقود المجموعه اللي هي حاجه باهيه معناتها سي لي في داكومبانيومون. جاو معناتها الممولين، انا في بالي باش يقولوا لي فما مشكله التمويل. اور اسونسيالمون سيتي لاكومبانيومون، اكلي واحد يشدوا من يده ويعاونوا، وساعات مش يشدوا من يده سامحني يدز، وانا مستعد باش ندز وبديت ندز. ما تتغشوش مني باش نطلب منكم اللي يهبط وعنده ايدي ولا ان بروجي في السونتي او موا يجيب حذايا وزاره الصحه تعرفوها في باب سعدون فما شويه سيركولاسيون هذيك وقت ليشابمون ودرا شنو اللي دونك ان شاء الله ربي يوفق الجميع اينما كنتم واينما كنا. والصحه وبلادنا مثلا انا نخدم فيها الحمد لله وما عندي حتى مزيه، كسوا اليوم ولا غدوه ولا البارح في المؤسسه العسكريه راهو وين يحطونا نخدموا ونتصور معناتها العباد الكل. هذاك معناتها واجب علينا الكل، كما واحد عايش باش يتنفس العمل والنجاح هو لا دوفيز نتاعنا. فما مثال نقولوا احنا نقولوه: من اجتهد واصاب فله اجران. تعرفوه ولا نسيتوه؟ من اجتهد واصاب فله اجران. ومن بعد ما فماش من اجتهد ولم يصب. اللي يجتهد لازم يصيب، لازم ينجح. على هذاك ساعات نحضر في هكاك لي كومبيتيسيون نتاع دي ستارت اب، اكلي الاول والثاني والثالث يعطيوهم جائزه 1.5 مليون و500 مليون دينار. قل لهم باهي رقم 10 وينه؟ لا ما نجحش. علاش؟ بالك شي ما عرفش كيفاش يكمل البروجي نتاعو، بالك شي عنده تمويل، بالك شي فما في معناتها في الميثودولوجي نتاعو من الاول فما حاجه كي كلوش. بالعكس راهو كل واحد عنده فكره ويحب هو الى اوزي متر ان بروجي ويمشي فيه. انا بيرسونيلمون نعاون العباد الكل مادام هو ما تسامحوني تجرأ وجاب بروجي من راسه. والا مثلا ما نعرفش انا فما حاجه عجبته هكايا عمل كرهبه صغيره فيها 3 بلايص تمشي بالكدا، عمل باش ما سالش نقول ماكينه صغيره تخرج الماء من فكره اللي احنا نشوفوا اسمه الماء كي واحد في الطريق بعيد ولا يشوف حاجه كاينها ماء سراب ميراج معناتها حاجات يجي هو مخه اكثر من الاخرين، هي مخه اكثر من الاخرين، والعباد الكل اللي هوني حاضر واللي مش حاضر مخه أكثر. كل واحد عنده ينجم يكون نابغه في مجال معين. ايه نعاونوه نحطوا لاباغي هذيك في سبيطارات في مدارس خاطر نستحقها. والامثله عديده، راهو الامثله عديده مش نحكي على اللي موجودين هوني برك خاطر شفنا كهرباء وشفنا آلة تتكون الماء وبرا تخرج 8 لترات في النهار هكا 8 لترات 30 وينو 30 في النهار في ال 24 ساعة شوية. لكن معناتها شو احنا عندنا مثلا في التقلب معناتها في التغيرات المناخية، قلة الأمطار، الجفاف، ندرة المياه. انت كي نحطوا الآلة هذه مثلا في مدرسة يجيوا الصغيرات يشربوا منها. تعرفوا مثلا في تونس ولا حتى هون في الإمارات فما تنجم تكون أماكن بعيدة على مصدر المياه، وما في تونس عندنا أماكن اللي الصناد نتاعنا ما تخلطلهاش. نجموا نوفروا هذاك باش الأطفال يلقاو يشربوا في مستشفى. معناتها أفكار تظهر كأنها شبيه ما جاتش البالي، مسألة جات البالي هو ما نقولوش لاش بيه ما جاتش البالي، انا جات البالي هو ما نمشيش معه، نمشيو مع هو والامثله عديده. فكل الشكر كل التقدير لكم الكل، ربي ان شاء الله يوفقنا ويوفقكم، وان شاء الله ديما نلتقيو هكا في حاجات باهيه. سعيد جدا بعد حتى كان انتم ما تنجموش تجيو الكل نجيكم. خليكم تكتموا على رواحكم ان شاء الله بالتوفيق. سي فريمون تري كونتون.
احنا حضورنا في هالموقع هذا نشكر سعادة سفيرة الإمارات العربية المتحدة اللي رحبت بنا في الصيف اللي فات، ونشكره شكرا جزيلا لسي محمد الزمرلي اللي باش يقول لنا كلمة، لأنه لو كان مش التنظيمات بتاعه هو ما نوصلوش للي وصلنا له اليوم. سي محمد.
شكرا سي منير. أنا اليوم أخجل تواضعا أمام هذه النخبة النيرة. تقريبا سيد الوزير احنا أمام بنك نتاع أفكار فيها كثير من التطوير التكنولوجي والتي نجحت، أمام أفكار مشاريع فيها كثير من التجديد طبقت ونجحت. أعتقد أنه فرصة كبيرة نتلاقاو، ما نجموش نتلاقاو في كل وقت. هذا بفضل سي نجيب،
بفضل انتم الكل
اللي كانت عنده هذه الطاقة للجمع. جايين من كل مكان سيد الوزير، احنا شرفتونا نتلاقاو هنا، ان شاء الله نتلاقاو في تونس وفي اي مكان موجودين. شكرا لك سيد الوزير على دعمكم. حبيت فقط نختم، مانيش ممكن ندخل في امور تقنيه، لو تحبوا ندخلوا بعد حول اهم السياسات الوطنيه باعتبار تولى تنسيق من المستوى التقني السياسه المناخيه الوطنيه. حبيت نشكر شكر خاص لكل الدعم اللي لقيناه قبل ما نجيو لهنا واحنا موجودين هنا، لمعالي السفير سفير دولة الإمارات الشقيقة بتونس أخجلتمونا سيدة الوزيرة بكرمكم خلال فترة الإعداد، وبكرمكم وإحنا موجودين هنا. إحنا نشكر كثير دولة الإمارات لكل ما لقيناه من تسهيلات ومن كلام ضيف. وكذلك حبيت فقط نختم، نعرف اللي ما يحبش أما لكن مش نقولها، اعترافا بالجميل معالي سفيرة الجمهورية التونسية بأبو ظبي. جيت هنا في أكتوبر، أريد كثير من الترحيب اللي تجاوز العمل وأقول وواجبات العمل، وكيف كيف موجود معنا. على كل شكرا من الأعماق ومن القلب سعادة السفير.
على فكره راهو ما جيتش حتى سي محمد قال لي يجي، قال لي راهو جماعه نحبوا نستدعوك، قلت له لا ارفض الدعوه، خاطر انا مع سعاده السفير ومع الفريق. قلت له انا نحب نمشي لخياتنا واخواتنا واولادنا واولاد تونس كيفاش يقولوا معناتها الكيب التونسيين اللي موجوده هنا. ان شاء الله ربي يوفقكم. حتى البارح تلاقينا في الطائره فما وجه تبارك الله معناتها شباب تونس معناتها حدايا 23 تبارك الله معناتها يصلج الصدر بالحق. صافي فريمون بليزير، صافي فريمون بليزير معناتها شباب تونس. مي اللي كبر شويه راهو مازال هو ينجم يعاون. يعطيكم الصحه. تفضل.
سلام عسامة، مرحبا بكم في دولة الإمارات العربية المتحدة الشقيقة. نرحبوا بالوفد الرسمي التونسي اليوم مع معالي الدكتور علي المرابط وزير الصحة، يشرف على يوم سايد ايفنت الأحداث الجانبية ليوم الصحة، وكان في لقاء متميز مع نظير وزير الصحة الإماراتي. بعد يومين نستقبل معالي الوزيرة ليلى شيخاوي وزيرة البيئة، تمتد زيارتها إلى غاية يوم 11، وعندها كثير من اللقاءات الثنائية مع نظرائها من الحكومة الإماراتية، وباش تكون لقاءات تسعى إلى مزيد تعزيز العلاقات الثنائية بين البلدين في مجال الاختصاص في المجال البيئي. مرحبا بالوفد التونسي من القطاع الخاص، من المؤسسات العمومية، من الوزارات التونسية في أكبر حدث عالمي مؤتمر المناخ كوب 28 اللي يعني مستقبل البشرية والقرارات اللي باش تصدر عنه والإعلانات مرتبط بها يعني مستقبل البشرية والمناخ، وهو موضوع هام وهام جدا. اللي نحب نقوله كل من موقعه، أي واحد من موقعه التونسية الإماراتية المتميزة وتشهد يعني تميز في كافة مجالات التعاون، مش في البيئة فقط، في كافة مجالات التعاون. فما آفاق واعدة في العلاقات، كل من موقعه يسعى إلى مزيد تعزيزها وتثمينها خدمة لمصلحة البلدين والشعبين الشقيقين. مرحبا بكم مرة أخرى ومرحبا، أهلا وسهلا.
السلام عليكم. على السلامة، صح؟ يعطيكم الصحة إن شاء الله. وأنا بصراحة جدا فخورة وممتنة أني قاعدة مع سفراء تونس في دولة الإمارات، فمرحبا بكم، مرحبا بهاي الطاقات الشبابية الرائعة، مرحبا بكل الموجودين أمانة. وبصراحة يعني أنا أحب أن دائما أتكلم من قلبي على أساس أنها توصل لقلوبكم. طبعا معالي الوزير وأخويا سعادة السفير وأخويا محمد وين راح ما قصروا. أنا بالنسبة لي دائما أقول أن تونس ما شاء الله فيها طاقات شبابية واعدة، فيها يعني بصراحة أنا بهرت في مستوى الطاقات الموجودة عندكم سواء كانت شبابية وغيرها. زرت العديد من الشركات الستارت اب كومبانيز، يمكن الأخ إيهاب يعني وأبو بكر طبعا والكثير منكم يمكن التقينا مع بعض. بصراحة يعني دائما أقول بالرغم من الصعوبات اللي موجودة والتحديات الموجودة، إلا أني شفت أن الشباب التونسي عندهم طموح غريب، عندهم يعني إصرار وعزيمة، وهذا الشيء اللي إحنا نبغى أن كل الشباب العربي يتعلمون منكم أمانة. في إصرار، في عزيمة، وبنفس الوقت في نجاح، وهذا الشيء جدا مهم. فما شاء الله يعني بالتوفيق للجميع. وأنا عن نفسي أحبكم برشا برشا برشا. وإن شاء الله دائما البيت الإماراتي دائما مفتوح. وحياكم الله في أي وقت، سواء كان في سفارتنا في تونس أو سفارتنا في الإمارات. إحنا فريق عمل واحد ودائما متعاونين، وإن شاء الله معا نعزز من العلاقات ونخليها توصل لأعلى المستويات. وأتمنى أني أنا أقدر أخدمكم ولو بشيء بسيط أمانة يعني. يعطيكم الصحة. شكرا.
شكرا سعادة السفيرة، شكرا سعادة السفير، شكرا سي محمد، شكرا معالي الوزير. ربي يبارك فيكم، وإن شاء الله عندكم تكملوا الاجتماع متاعكم واحنا باش نكملوا الاجتماع متاعنا. ربي يبارك فيكم. شكرا. Who's next? mic on?
I think so. Yes, it is. It is. Hello. Hello and good afternoon again. Excuse me. So we have another presentation today with talks about another technology presented by Hichem. Let's together discover this amazing slides. Then we'll learn about new technology and new artificial intelligence.
Yeah, so thank you very much, Mr. Sofian. Very pleased to be here today among all these TTU leaders. Big thanks also special for Mr. Najib, who was the contact point actually with whom I started, and I'm here today. I will do it very shortly. We are approaching lunchtime, 7 minutes. So, Mr. Hamdi presented very well the problem with methane leakages. So methane is actually contributing to 15% of GHG gas emissions. It has more heating impact than CO2, up to 80 times in short term, I mean in the first 20 years. And just the losses in USA about the leakages is over $2 billion US. Mr. Hamdi, you are solving this leakage problem. Please don't do it 100% so that you don't kill our business because we got detected leakages. The problem with methane, it's invisible, and the devices used to detect methane are quite expensive. So the infrared camera, just here the FLIR camera, typical used camera, we are speaking about above $50,000 just for one camera. 120. Yeah. And all about this, we have high uncertainty about real methane emissions, perhaps around 70% uncertainty, even with all the reports that we are seeing. So space, satellites can play a crucial role, really, to detect such methane leakages. But the issue with satellite imaging, actually we have two types. We have the open, free satellite imagery, mainly offered by the European, American space programs. So typically anywhere in the world, we have one free image each 5 days, and it's freely accessible. But the issue is low resolution. On the other side, we have commercial satellite imagery providers, private companies, but the issue is price, very high resolution. Just a single image may cost up to $15,000. Minimum acquisition size is 5 by 5 square kilometers, which is a barrier for adoption in most economic sectors. And Mr. Mohammed, I don't think that you're allowed to spend like 5,000 or 15,000 to detect a leak. And our solution for that is what we call super resolution. And it's based on AI and advances in AI, in generative AI. We have architected and trained an own AI model with thousands and thousands of pairs of images, low resolution and high resolution. And now the model has developed the capability, now based on the free open satellite image, it's able to artificially enhance its resolution to bring it as close as possible to the commercial quality. And here's the result. So again, this image is freely, it's generated from the free satellite image. And this is only, the example here is what we call visible images, so RGB. We have what we call multispectral images in the infrared spectrum. And we applied the same technique of super resolution on those multispectral images. And as a result, here, I'm showing just an example of the thermal image. Here, the raw satellite data, low resolution. And once we apply the super resolution, we begin to see streets, buildings, so down up to 5 by 5 meter resolution. Now, this is in itself a product that we are launching as NextAV. We are a geospatial startup, so we are launching this as a product. But we need to educate the market about the potential of this technology. And one of our, potential use cases that we are actively working on and launching beginning from next year is what we call, methane detection, oil and gas leakage detection based on from free satellite imagery and what we call continuous. So on a bi-weekly basis, we will take free satellite imagery, apply the super resolution technique, and from there, detect methane leakages. And here, a few examples. What you are seeing in red here is what we call the ground truth. Those are data that are validated on ground with handheld sensors. And what you are seeing above are actually the detections that we have made based on satellite imagery processing. And because it's based on free satellite imagery, so on a bi-weekly basis, all over the year, we can offer cost-effectively the service for our customer, the continuous monitoring of oil and gas infrastructure to detect methane leakages. Just about the colors, we are starting, the detections are starting from 1,000 ppm. How to fix this problem, and this is what Mr. Hamdi, in many cases, it's as simple as, strengthen one ballon and or to fix a leakage, and
tightening the bolt.
Exactly. And the beauty of this, the big impact, just reducing by 45% the methane leakages, we can really prevent a potential increase in the planet temperature with 0.3 degrees, which is really huge. Our vision in our startup, we started with products that are based on satellite imagery processing and a vision to fuse data with airborne IoT collected data to build what we call the digital twin of our customer assets. And through AI processing, we are generating interactive dashboards, automatically show statistics and flagging issues for human review, reducing time to insight so that actions could be taken in time. But the market is much, much bigger for this technology. Just to mention agriculture, forestry. When we speak about public authorities and governance, on a country basis, we can generate interactive dashboards showing many statistics about many economic activities and environmental parameters. We are a 2 years bootstrapped startup, currently with 7 full-time team. We have a monthly recurring revenue of $5,000, and we are actively looking for our investment tickets. I'm very happy and lucky to be backed by a strong technical team. Our CTO, Bouhlel, is an internationally recognized AI specialist, official NVIDIA instructor in our region. And Amin is taking care about our cloud solution. We are offering SaaS services, but our cloud solution is meeting the international standards. And I personally, I'm bringing several years of experience from Germany, mainly on airborne remote sensing. So we used to equip multiple drone systems and 2-seater aircraft with multiple types of sensors and generating maps over large areas. A complementary technology for satellite imagery that we are doing now. And we have trained and hired our young technical team, and we are actively building our advisory board. But we are, TTU is one of the best sources, let's say, to build our advisory board. All this would not have been possible without strong partners like Microsoft, NVIDIA. We are speaking about computational intensive solutions. We got a grant from Microsoft with 150K as cloud resources. The same with NVIDIA Inception program. We are relying heavily on those cloud resources to build our solutions. This was very briefly, and I will be very happy to exchange with you about potential collaboration. Thank you very much.
Thank you. Thank you, Hichem. Brilliant presentation. We'll discuss. We'll have a lot of things to discuss later on, I think. Now, the next presentation, it will be through Dr. Kamel. He will continue talking about technologies. It's today's technology space, this panel too. So, Dr. Kamel, floor is yours.
Okay. Thank you very much. Assalamu alaikum. Very good morning to all of you. My first words are to appreciation for Tunisian Talent United. They are doing such a wonderful job to return to optimism for Tunisia. And country needs that. Congratulations and many more successes to come. Thanks also to the Tunisian delegation, Mohamed Ismaili and his colleagues have been extremely supportive. So I'm not going to bore you too much about technology and so on. I just wanted to talk to you about some of the concepts in this startup. And if we look at some of the things I have done in my life, I don't have, let's say, the experience of seeing Najib, but, about 25 years ago, I was called in. I was working in the oil and gas sector, and the CEO of the company I was working in called me once in his office. I said, this is not a very good news. Why does the CEO of this very huge company want to talk to me? And he said, you know, Kamel, there is this thing called carbon capture and storage. Can you look at it and come back after 1 year and tell me, is there something that our company can do? And this was a discovery for me, because I was in the oil and gas sector, and we deal with all the companies and so on. On carbon capture and storage, we dealt with very different stakeholders. All the climate people, all the environmentalists, all the policy makers, the regulators, and so on. So discovering this word was fantastic. And so many years after that, after I decided to take the foot from the accelerator a little bit, I decided actually to think about what I can do as a starting business. And I was inspired by my son, my first son, who actually, we call him in the family Mr. Startup. And he's been very successful creating startup in US. The latest one got significant funding as a startup in artificial intelligence. So I said, okay, I cannot be passed on by my son, so I'll try to. And so this is how Damorph actually started. And need to see. Okay, so basically what Damorph is a company that is based on nanotechnology, and I will tell you in a few words what nanotechnology is about. It's actually the intersection of a number of areas that nanotechnology is applied. It's used in healthcare, in consumer tech, in energy, in agri-tech, in space and defense, and in human being applications. And so that's the, if I get it to work. We got together as a team, and you see here the people of the team, very international. We have obviously people from Tunisia, people from China, from India, Turkey, US, UK, India. And so these people were actually the people that got together to put together their skills. And what we were looking for, people with innovation skills, people with commercial skills, and people, I go back to Mr. Mohammed speech earlier, you need to have a strategy. You need to have a vision. And so the strategy and the vision is what puts it all together. So what are nanotechnology? And I want to show something from nature, is actually, these are very small particles. They are nanometers. It's not millimeters. You have to go 6 scales down to go to the nanometer scales. And the best example is nature. If you look at butterflies in nature, they have different colors, they are beautiful, but actually it's nanotechnology in those butterflies that makes this very rich combination. And I would suggest you Google, put butterfly and nanotechnology. It's amazing what that. So what we are doing is we are using some very fine particles, nanometers particles, and now we're integrating them with different materials. And so what we are doing on these materials, like steel or like copper and so on, we are enhancing the properties of these materials to become much more resistant, to be much stronger, so we can transform things into metals like tungsten, which is much more expensive, or even diamond, with only adding small particles to those metals. So that is what nanoparticles are about. And so what we are doing is, these are some of these nanoparticles that we are. Where did we get all the knowledge? Obviously from knowledge, but also it's very much used in very advanced applications in the aerospace industry, in the defense industry, to enhance the properties of materials. So the strength of the materials is shown by this graph, where we show some of the properties in terms of temperature rating, strength rating of these materials. These are also other things that we do with these nanomaterials. We actually use them as tracers. These are very fine particles that you cannot detect with visible eyes, but you can look at them using tracers, which are some lights, and then you can distinguish different colors, so you can identify where which nanoparticles are when they come back. We are also integrating them to some materials. Donc Hamdi talked about some of the materials we use. We use them also on things like we call nozzles. Those nanoparticles that are currently used also in medical application as tracers. When you want to do a scan of lungs and so on, this is where you use these nano tracers. So all these are together. And examples, some of these are going through hundreds of colors for these nanoparticles. What we have done is created a center of excellence for materials where we can develop all kinds of materials from corrosion-resistant alloys. We can go to a different amorphous alloy, and then some materials with artificial intelligence that can have some dedicated properties. An example that we have used, for those of you that are in the oil and gas industry, we do what we call perforations. These perforations are like bullet holes that we do put in wells to enter into the formation and produce back the oil and the gas. These are perforations. So what we do is we take those, what we call liners, and we incorporate those nanoparticles in the liners, and then we get them to be a much, much stronger material. So when you try to use those perforations, you get a much larger entry, and so you can produce more hydrocarbons and lose less fluids. We also integrate those tracers with those charges, and so now we can do detection from downhole, thousands of meters, where is this oil coming from, and we can do it with those tracers. We can also use it for environment, because sometimes you have pollution, and we can define where this pollution is coming from. So we can find who is the bad guy who has been emitting those nasty fluids into the sewage system and so on. So these are some of the things that we can do. Another application that we have started is in geothermal. Geothermal is actually what we are doing. You have a well where you inject some fluids, and then the fluid goes up and then to another well, which is a production well. So the water gets into steam and then heated by the temperature downhole, and then it gets produced. So that steam is actually generating energy. So this is the concept of geothermal. And what we are doing actually, because some of these wells are at very high temperature, they're at 450 degrees Celsius, much higher than what we have in oil and gas. So what we are doing is we're developing new materials in the production wells and the injection wells that can go to these 450 degrees Celsius. And this allows actually to develop a completely new technology. It's called super hot rocks. And this region and North Africa have a very high potential in this super hot rocks. These are some of the systems that we have developed, and these have been actually with the funding of the Nippon Foundation. And actually we have been receiving awards for this technology from that. Other sectors that we are looking at is actually in medical sectors, where we are looking at some of these nanotechnology to repair bones in a very effective way once they have unfortunately been fractured. So we can incorporate some of those to increase the strength of the bone and allow it to be to heal in a much faster way. Another application that we are also looking from those chargers is that we have developed a patent on using those chargers from an aero system through drone. So you can drop those chargers and actually plant seeds in areas that are very difficult to access, like in the desert or other areas that could plant seeds and stop the desertification. So that's the concept, and this is actually what we have actually developed. We have been awarded, actually being finalists of the award of one of the biggest competition for startup companies in a couple of years ago in ADIPEC here in UAE, where we were rated as one of the top 3 startups. There were 700 applications from around the world, and we were very pleased to be among the top 3 from 50 countries. So just a summary, Damorf is an advanced materials company focusing on the application with sustainability in our DNA. Nanotechnology are inspired by nature. Applications that initially were in the oil and gas industry are now moving to low carbon energy, such as geothermal and wind. Some of the technology that we have developed are actually being considered for use in the medical and the agricultural sectors. We have actually been selling them to US, Canada, Middle East, and Latin America. And Damorf is an example of talent across the border. Tunisia features highly. We have also colleagues from other ones. Just final remarks is that as a startup, we decided to take a strategy of being self-funded through grants from foundations and others. It has been quite successful because it has allowed us to be free of our developments. And we are looking forward, actually, 2024, to break the $10 million revenue as a company. So with that, thank you so much and wishing you all the best.
Thank you, Dr. Kamel. Thank you, Dr. Kamel. We learned a lot as usual. Huh? Now, Dr. Huda for her presentation with regard to the our lovely sea, our Mediterranean that we are sharing with other countries. Dr. Huda.
Thank you. Thank you very much. Good afternoon. Good morning. I don't know what time is it. First of all, thank you very much for inviting me, but I'm very glad to be here. Thank you to TTUS.
May I help you?
It's okay.
It's okay.
It's okay? Do you hear me?
Yeah.
Okay, great. So I'm very glad to be here, and I will bring you back to Earth because we've been traveling through many inspiring technologies and examples, and then would follow with what we've heard about the global challenges for the energy sector in the global level and what we need to do in order to reach this decarbonization that we have to and achieve the targets of Paris Agreement, focusing on the Mediterranean region. So I'm Dr. Huda Benjanet. I am General Director of the Organisation Méditerranéenne de l'Énergie et du Climat. Those who knows me, we used to name our organization Observatoire Méditerranéen de l'Énergie. So this is a more than 30 years organization which is gathering Mediterranean energy companies. We are neutral, so we are not. We are dealing with all energies and neutral. And the focus is our daily job is to analyze what is happening in the energy sector, and also one of our flagship activities is to make scenarios. And in our scenarios, also we do not take position. We only try to translate the impacts of the policies and measures, and also alternative scenario with which all what is happening around us. We are the voice of the energy industry, gathering platforms, think tank, and also training. And we are very honored, of course, to have Tunisia also among our members through STEG and ETAP, the two companies that are one of the founding members of OMEC. So today I'd like to share with you the outcome of the Mediterranean energy perspective, which we have prepared for COP28 with two scenarios I'd like to share here with you. One of them is co-financed by the European Commission. We were asked by the European Union declaration, ministerial declaration, to look at what could be the journey to decarbonize the Mediterranean region by 2050. So we released officially map yesterday, but here I would like to share with you the main outcome and messages. Okay, so this is based on our own model, and we have only 3 exogenous variables. We take into consideration population growth, prices, and GDP. So we have in our publication 2 scenarios, as I said. The first one is not really a reference scenario in the sense of business as usual, but we take into consideration the unconditional NDCs that are proposed by the Mediterranean countries, because we consider that this is a commitment from the countries to reach these targets, whatever the scenario is. So unconditional NDCs, and we see what would be the energy future if we only reach the unconditional NDCs. And I have to say that we have more than 30 years of existence, and what we see, unfortunately, is that what the reality, we have a sort of reality check. The reality is showing us that we are much more close to the business as usual than the alternative. I'm speaking about what is happening in 30 years. So this is the reference scenario, and then we decarbonize the Mediterranean region by 2050, and we look how is this going to happen. Disappeared? Okay. Fine, this is not the presentation, but anyway. So we are about more than 500 million people today, the Mediterranean as a whole. When we say Mediterranean, this is all the countries bordering the Mediterranean region, including Mauritania, up to Portugal. Jordan is also included as a Mediterranean countries. So 500 million, we are more or less 7% of the population, consuming 7% of the demand. That's quite equity here. We pollute less than 7%, and we contribute a little bit more with the GDP at the global level. When we look at the perspective, what is going to happen, according to international organizations, this is not us, of course, to say that, is that the growth is going to be driven by the south. So the growth up to 2050 will be driven by the South Mediterranean countries more than in the north. First thing. Second thing here is the population increase. In the North Mediterranean, we are going to decrease the population as compared to today's levels. About 14 million less people in the North Mediterranean countries than today. Whether we will have more than 120 million people more in the South Mediterranean countries. So this is what is expecting us according to the prospects. And still, when we look at the indicators, we see here that we will still have some inequilibrium between the GDP per capita between the north and the south, though the gap in percentage will decrease, but still in the north we will produce GDP per capita more in the north than in the south. So the challenge for the south countries is quite huge, not only because we have to develop our economies, but also we have to fuel these 120 million people coming in our countries. So what would be the consequence on the energy demand according to the 2 scenarios? So if we only, so here you see that from 1990 to 2020, the energy demand in the region has decreased by 43%. If we go for unconditional NDCs, we will keep growing, and we will have 30%, which is a little bit less than 43%, but still. So we will increase the energy demand in the Mediterranean region by 30%. However, if we need to, we are to decarbonize the region, we need to have an energy demand which is 20% lower in 2050 as compared to the today level. So just imagine 120 million people more, but altogether we are going to consume 20% less than what we are consuming today in order to decarbonize the region. And this is a potential of 37% of energy demand to be avoided between the unconditional NDCs and decarbonizing the region. Here, the reality. Where are we starting from and where are we going? We may go or we would like to go. You look here, this is the energy mix in the region divided by North and by Med. First thing you see, this decreasing reference scenario is unconditional NDCs, and here we decarbonize. The same here. You see that whatever the future is, the North is going to decrease its energy demand, or by 20% or by 37%, according to if they decarbonize to the maximum or not. But in the South, we have completely two different stories. Or we double our energy demand until unconditional NDCs, or we keep the level and we increase only by 6% if we are to decarbonize. Second issue, striking for the South Mediterranean, is the colors. Here, more or less the same. We see that it is greening, so renewables are taking an important role. Nuclear will keep a role, and we are reducing hydrocarbons. And so natural gas will keep a minimum role in the decarbonized scenario, but anyway, otherwise, we have less hydrocarbons and more renewables, so we are greening. Here we have two completely different stories. Or we keep, so we have here, our economies are 90% based on hydrocarbons. This is today, 2023. And we're talking about 2030, this is 7 years. And then 2050, we have more time to indeed make things happen, changing faster. So this is, the unconditional NDCs is telling us that we will keep at least 70% of the energy demand in the Mediterranean region based on hydrocarbons. And again, we are neutral. This is not a position. This is a consequence of what is decided within the countries and the NDCs. If we want to decarbonize, then we need to very much accelerate, of course, reduce drastically or avoid consuming energy. So drastically increase renewables. Nuclear will have a certain role in the two scenarios, it's the same. Then natural gas, we like it or not, hydrocarbons, as you said, will be still needed. Even if we are in a decarbonized scenario, they are needed. We are talking about the transition. We are not talking about a rupture. So this is a very important message that we all need to integrate. Renewables. So here you have the today level. We have 13% of energy, renewable energy in the energy mix. And we have, we will reach 20 to 23% regarding to the reference or decarbonizing, and very important increase, of course, will happen 60% by 2050 if we are to decarbonize the Mediterranean region. So the current level of renewable energy demand will have to double by 2030 and quadruple by 2050 to achieve. And here I have to say that we are not in this exercise taking into consideration exports. So this is only closed door, I would say. This is, I explained it. So energy efficiency, you have seen a big gap. We have to reduce by 37% between the two scenarios. So where do we get this energy efficiency potential? So 35% transport. Of course, we electrify the cars, so we started, and congratulations, by the way. We are very proud of that. Industry, residential, and other sectors. So all sectors will be contributed in reducing the energy demand, and the transport sector will play a role. Decarbonizing, we all know, means electrifying the economies. So if we are going to decarbonize, we are going to electrify the economies. And here we see the difference in terms of the electricity share in the end use. So today it is 70% based on fossil fuel. If we are to only go with unconditional NDCs, it will still keep 60%. But if we go to decarbonizing, then we electrify massively. And in that case, electricity and renewables will play the major role in the end uses. So power generation, this is, you see how renewables will play an important role in all scenarios. And here you have the situation in the South Med. So if we are today, we are 21%, and we will have electricity, which is the easiest, by the way, to decarbonize, is the electricity sector, and renewables might be represent 78% of the power generation in the Med, and solar and wind are the most important and promising resources for our region. We know that energy is a problem or a good news, depending, but it is rather a headache sometimes. And energy dependence and energy security is an issue. It's not new, but indeed, the crisis that we've been going through and the Ukraine-Russia crisis has reminded also the world that energy security is an issue and we have to take care of it. What's happening in the region is that today, so here you have the north, the south, and the Mediterranean. So if we are all in the same boat, which we are not, we are dependent 37% from outside for the energy. And we see that by 2030 or 2050, let's say take 2050. So we have two contrasted situations. So if we only go for unconditional NDCs, we will have the rate is lower, 32%, but in terms of volumes, we will need more volumes. However, if we decarbonize the Mediterranean region, then we will turn from net importer to net exporter. This is first for the region. And now when we look at the bad news, is for us, again, for the South Med opportunity. I don't know how to take it, but today we are only 6% dependent, the South, altogether, same boat. If we only go for unconditional NDCs, we will need to increase our energy dependency and to reach 29% with much more volumes. However, if we decarbonize, then we will have an export potential which turns the region to be export 55%. So this is completely two different, of course, pictures, and which have also consequences, not only on the energy sector, but on the economies. Should the countries be producers, but then they will have to consume what they produce, and their export potential will be reduced, or even some may turn from exporter to importer. And for the importing countries, so this is a very bad news, of course. So CO2 emissions. We are not well known, unfortunately, the Mediterranean to be the climate hotspot. And whenever the climate change is worsening in the world, we are going to suffer from it more than outside. And so here we see the difference between, in terms of CO2 emission, between the two scenarios. So here we decarbonize, so it's okay. But if we don't decarbonize, the unconditional NDCs will bring us to increase the CO2 emission for the region by 38%. And here you have the path to get there from CO2 emissions increasing to decarbonizing. How to get there? We need all technologies. By the way, when I talked about renewables, because it is not mentioned here, storage is very important. So it represents some 10 or to 15% of the electricity capacity, because if we don't have storage, we will have problems also with renewables. So in order to decrease this, we have to tap, but right now, start now, because you know the inertia for the energy system. From now on, avoid, we can save 46% of these emissions by energy efficiency, by renewables, sorry, 46% renewables. So we have to accelerate the development of renewables in our countries. Second, energy efficiency. So both renewables and energy efficiencies, they represent 89% of the CO2 emissions avoided between the decarbonizing the region and conditional NDCs. So energy efficiency, renewables, but as we have said, we need still hydrocarbons, and the issue is not hydrocarbons, the issue is the emissions indeed, and so we have to have access to clean energy service. We don't care with what, if it is a clean by the end of the day. So we will need green gases and also, as mentioned, CCUS in order to reach the decarbonization of the Mediterranean region. So this is how it is between regions. So the North Mediterranean countries will reduce drastically its CO2 emissions, whatever will happen. But in the South, if we don't accelerate the efforts that will be made by, this is the reference, NDCs. So Europe and North Med will reduce their emissions, but we, all together, we will produce more. So the efforts made in the North will be killed in the South. So that is why, and we said this is a global problem. So we need to address it all together. MEP is in line, fully in line. We didn't made it by purpose, but as you say, we made our estimation and prospects, and we compared what would mean decarbonizing the region in terms of renewable energy and energy efficiency, and we are absolutely in line with this global pledge, which is announced here in COP28. So the win-win strategy is also to rapidly foster and develop renewable energy and energy efficiency, but work also on all technologies altogether, existing, and also prepare the future, because what you have been talking about is here, happening here today, and we have also some are for the future. This is costly. So we have estimated how much it would require as investments in order to reach this decarbonized scenario, and so we estimate that 7 trillion euros will be needed in the Med in order to reach by 2050 a decarbonized system. So to conclude, all have been said already. So we need to foster renewables. We need to foster energy efficiency. Electrifying means that we need also to interconnections, because this is very much needed otherwise. And most importantly, no single country can make it by itself. We need to go together. No one can make it alone. So we had good examples of indeed, congratulations or startup, but mixture of capacities from different countries. We have same problem, therefore we are in the same boat, which is, as you've heard, we need to save the planet, but we need to save it for our own and also the generation to come, but no one can make it alone. So we need to work together, and hopefully we will reach, probably not the zero carbon. We have to be realistic, but we must be optimistic and realistic in order to be really on the safe side. Thank you very much.
Thank you, Dr. Huda. A lot of passion in your presentation, and it's much needed for our planet, for the Mediterranean, which we are part of this Mediterranean Sea. So now we'll start the QA session. If you want, we'll start with the technologies, and we'll start with Dr. Kamel. And so my first question, your side talks about very high-end technology, which is the nanotechnology, and I would say how this nanotechnology today can contribute to the energy transition today.
Thank you very much for the question. I think that you know, we need to move away from this very heavy use material like steel and so on that are very much consuming energy and generating emissions. We need to be much smarter in the use or in the production of materials. Some plastics are, with the caveats, are an example, but the materials that are smarter with nanotechnology is a response, because they can take you much further away in terms of performance. We all heard a few years ago, we had the graphene. The graphene is a material that is coming from carbon and with extraordinary properties. We are doing the same thing with nanoparticles now.
Mm-hmm. All right, thank you. Thank you, Dr. Kamel. Maybe, I would continue with the same purpose and the benefit of the society out of them from this nanotechnology.
Yeah, so the society would benefit because, one, we would be able to do things we were not able to do before. Like, for instance, geothermal applications, which this region, I think I've just seen a study that Saudi Arabia alone has a potential of 2.3 terawatt of super hot rocks. But the key is actually to have the material that would allow you to go and get this this energy. This energy is below our feet, and it's abundant. So these are things that we can do, and these are enablers for the
benefit of
benefits, and this is clean energy.
Very clean energy. Thank you. Thank you, Dr. Kamel. Maybe I will go to the technology of the solution that you have proposed.
Flange management.
For the flange management,
yep.
I would say flange management or bolted joint management
right.
in general, and how the conventional and the new solution that improve the alignment of the flanges and reduce the emission. I refer to the case study that you have done, but I would say I'm really curious if you have done a campaign of emission measurement before and after a campaign of the HYTORC, let's say tightening or aligning the flanges in order to reduce the emission. Have you done this this case before and after the tightening the flanges?
Thanks for the question. For sure, it's part of the pitch deck. So you need to justify the cost behind that investment. So what we pitch is the direct cost, or the direct answer to your question is, in terms of social costs, you will save $2,400 per ton of emissions. So if we eliminate the emissions after we do the surveys, in a typical plant is around 600 to 700 tons. So you do the math, you multiply that by 2.5K and you get your figure. That's in millions of dollars. Now, the other implications of leakage, which moving from fugitive level to a real leak, the leak which can cause damages to the environment, the spill, the safety. So if this happens and being detected, then we need to shut down the whole unit. And shutting down a whole unit within an oil and gas plant, that costs per day at least $2.5 million. So these are kind of implications if we don't follow the standards and also the procedures in terms of flange management and bolting.
Thank you. Thank you. It's very, very interesting indeed. Earlier, Rida, he mentioned that the goods and and people, they have borders, but the gas doesn't have borders. Maybe you have an answer for that, Hichem.
Yeah, thank you. It doesn't have borders.
Borders.
Borders. I mean, yeah, borders. Yeah, it doesn't have borders, and I mean, methane is now real problem. Just on the first day, Dr. Sultan has announced that there is now a commitment from the oil and gas industry to reach 0% methane emission by 2030. there is a huge, let's say, challenge to do this. What we are doing from space now is what we try. I mean, the current solution based on satellite, they can detect what we call ultra emitters, so big really emissions. But with this super resolution technique that we are defining, we can go as low as 1,000 ppm. So yeah, and to try to fix. And perhaps with the discussion with Mr. Hamdi, also we can think about new business models, how we can serve our customers. Exactly. Yeah, this is the point. I'm very happy for the coming discussions.
Thank you. I would add this that in line with the OGMP framework 2.0. So we know in order to reach to the gold standard, you have to reach to level 4 and do the level 5 in order to reconcile what you have done in the level 4, which is the direct measurement in the plant. And by your solution, it's the client will get the benefit to have the site survey, and they can reconcile and can have the gold standard for any asset owner who is looking for the gold standard for the OGMP framework. Thank you. If I go to Dr. Huda, so it's I'm impressed with your slide and your passion on the topic that you have mentioned, and this is as well which touch us, all of us, for the related to the Mediterranean Sea. In your point of view, what would be the human capabilities to achieve this objective?
Thank you very much. So human capabilities is very important at all levels, because if we wish to reach the targets in terms of tapping energy efficiency, developing renewables, technologies, innovation, we need people at all levels, from the toppest, in order to guide and to let us have the adapted institutional, regulatory, the conditions in order to make things happen, to the student, to the researcher. Just to illustrate this as an example, because I was inspired coming here by the car, and again, congratulations, and by how we can get water just imagine if I am given this car and I don't know how to drive it. And I try, I can make crash. So not only we need to have this, but we need that also I'm able to drive. So, and I could be a student, could be a mother, could be the president, could be a minister, so if you allow me. So this is absolutely fundamental to have the capabilities at all levels in order to set up the conditions in order to reach the targets, and also to have even the consumers aware to be part and play their role.
Thank you. Indeed, as you mentioned that, and we have all together to contribute in order to save this planet. And what about the risk related to the climate change in our region?
Well, unfortunately, as I said earlier, we are known to be the hotspot. And we are also known that if a disaster will happen, we will be much more affected by that. And we are already affected, that we are living this in our day life, whether in South Med or in North Med, with the floods and with what is disaster that we are living on. You have seen in my scenarios, if I look only to the energy, the difference between one and the other scenario, I would say it was, even if we don't look at it from a climate point of view, it is not good news in terms of energy security, because we are going to worsen, and we might have some also consequences even on the geopolitical issues. But I mean, we have to, because otherwise the cost of inaction will be much higher, which is, we have, unfortunately, I don't have figure now because we don't yet measure the externalities of inaction. So we know that we will be much more affected than the others. We know that we are already hit by all this disaster, and we have to avoid it. Therefore, for sure, the cost of inactions and what we are paying now, the economies for the disasters, will be much higher, and we have to avoid this as well.
Thank you. Thank you. I appreciate it. I don't know if you have time to pick up Yeah, yeah, a couple of questions. Yes, please.
Thank you. I have a question to Kamel. Mostly we don't think in terms of the whole life cycles of products, yeah? And as, for instance, when we come up with plastic, we didn't think about that plastic would be the sixth continent floating in the ocean, yeah? And this is why I'm asking, have you thought about the hazards combined with coming up with enhanced, with nanoparticles enhanced materials? What are the hazards? How can we recycle when the life cycle has ended and so on? Thank you.
So thank you very much for the question. It's very much up to the point. I think number one of the advantage of the nanoparticles is that when you incorporate them to materials, actually you manage to reduce the quantity of material to start with. So you have less material. The second point is that in terms, we design all the products with the what we call a circular economy concept, with the recycling as being part of the design of this material. This is a very important consideration for what we do. So these are the two elements that we select. One is that our materials are actually coming from normal materials, but incorporating small quantities of particles, these nanoparticles. And second thing, we design them with the recycling in mind.
Thank you. Thank you, Dr. Kamel. Another question? Yes.
One question?
Yeah.
Thank you. My question is for Dr. Huda. Okay. We are in the same boat and the boat will sink if we don't move. How to start to face this objective? How is the plan? Because I see a lot of figures alarming. And my question is how to start and when to start. Yeah. Thank you.
Now,
You're absolutely right. That is why I said I'm really scared because for 30 years, this passion is coming from the fact that I'm general director for OMEC only since 10 years, but I've been working for this organization all my career. So, and I've started, by the way, working on renewables and energy efficiency when nobody talks about it because what was late 90. And this is an anecdote, but it is not really a one. And when I took over the general director for me, I had to look at everything. So back, and I find myself now as if I was much more lobbying, and it's not lobbying for hydrocarbons. It is strange. And then I was telling to myself, I am making my career in the reverse because everybody was working for hydrocarbons. It's now clean and renewables and green hydrogen. And I was the one, I made my PhD on demand side management. And that today I'm a little bit embarrassed by this one way. So to answer your question, it is a big journey and we have a big challenge ahead of us because the way to get there is very not that easy, in particular that, as I told you, we're going to have 100 million people more in our countries, in our region. And we are also starting from a level of energy demand already, which is lower as compared to other regions. So the story is very huge. And we need to work all together. That is, regional cooperation is very, very important. From our side, modest side, as OMEC, we are having this organization gathering around OMEC in order to make things happen. So we also work a lot with other regional organization regulators, DSO, energy efficiency. We are trying to foster and hand in hand to also shake a little bit more those who can help regional corporations to foster. So we have to all work on the same direction, I'm personally very proud that our members have decided to move from observatoire to organization, from energy to energy and climate. And this is really not adding C for greenwashing. This is an illustration that energy companies have also made and are making their transition from sectoral approach to energy services, and they are joining forces. So we are in optimism, and I am optimistic person. I am also realistic. So it is, the journey is long, and we need to join efforts. Every single one can make things happen, from the perfect discoveries, will it small, and by discussing with those that makes things happen, to let them be aware that we need to make things faster, because otherwise, I don't know if I will be here, but in a couple of years, we come back and we will see that the scenario has evolved in the worst case, and which this is something that we don't want. So we give it a try. We hope to be successful. And as the minister said, maybe we will end with Ajrain, inshallah.
Thank you, Dr. Huda. So another, yeah. Another last question from.
Maybe you would like to close. Hi. Hi, thank you so much for the presentation and for the findings. And my question was about also the how, and maybe I'm going to guide you just a bit to see if there's an alternative to speak about the Union de Maghreb Arab, United Maghreb Union, maybe to start by the Global South. That was actually my thesis about the institutionalization for the Euro-Mediterranean partnership. And I found out that, gathering the South, because we have the same interest, the same ground, the same, we're in the red zone there. So don't you think that tackling it from a Southern perspective, or unite under the Southern umbrella, would be much better than, going through like the European Union? What do you think of that?
Thank you.
Once again, that was an example. As I said, we have to, as OMEC, we are bringing our added value and our contribution through our own constituency. And again, we have plenty of players, the regulators, the industry, the energy efficiency, so the TSOs. So we have a fantastic team that can implement, if we have indeed the means and the vision and the means also to reach. We believe, and I say again, regional cooperation is important. Of course, South-South also. It is North-South, South-North, but also South-South. We need interconnection from North-South. So we are concentrated on the Mediterranean as a whole, because we believe that we have interdependencies and complementarities. And so there is an issue of working together, but it doesn't mean that we don't need to work South-South, but also at a national level. As we said, we have to clean up first, and let's be strong and work with all the others. And again, then we have also international cooperation, because fighting climate change by the end of the day is a global problem. But there is an issue of working on the Med, because of these many opportunities, complementarities, and many issues that also go beyond the energy by itself.
Thank you. Thank you, ladies and gentlemen, for this expertise you brought it for us. We learned a lot, and I think we close the panel 2 today to go to the panel 3.
Well, before the panel 3, first, thank you very much for all the food of thought that you gave us.
Yeah.
We have been well served. Probably we deserve some food for our stomach.
Yes.
I'm not sure the security allowed us to have each of us a lunchbox. We received some of them. Some others are on their way. So I think we're going to make a small break, and I would like to invite Hichem. He's going to make an announcement. We have some drinks, but he has a better drink for us.
Thanks, Munir, and thanks for everyone. Really, it's an honor, and I'm really thankful for the support that we got from the Tunisian government to have the machine here, and from all the people that are here. That means a lot of people were encouraging us, and we're thankful. The machine came from Tunisia. Water has been tested. I tested it myself now, and and you tested it, and the machine was like, we've been selling the machine for more than 30 machines sold in Tunisia, in France, in Spain, hotels, major companies like PwC, Ernst & Young, and all of them are healthy now. So we offer you the water for everyone that is here. You can serve yourself, help yourself whenever you want. Thanks again, TTU. Thanks, Munir.
Thank you very much, Hichem. I think on COP28, everybody gets water in the bottle from the fountain. Only Tunisian pavilion has water in the pavilion. Bon appétit.
Merci. يعيشك.